live from NCI Summit. We're live. Here we are. Hi, everybody. Say hi, everybody. Hi, everybody.
Hello, everyone.
Oh, hi, everybody. Yeah.
Eric Kaiser here from TrueTech Tools for the Building HVAC Science Podcast. As I said, live from NCI Summit 2024 in Asheville, North Carolina. Bill Spohn over here.
Hello.
And Mr. Paul Wiebolt from NCI. Welcome, Paul.
Thank you.
We're going to have a little fun here for, 45 minutes to an hour, something along those lines. Going to talk about a whole bunch of stuff, maybe learn a little bit about Paul.
Yeah.
And Paul's got a lot of years of experience. I got into some really interesting conversations with him, and I learned a bunch of stuff, and I'm anxious to learn more from him in this conversation today. So this should be a good time. So let's get into it. Bill, take it away. You've got some questions for Paul.
Sure, Paul. I've known you for many years, maybe 15 years, 20
Yeah.
years. Yeah. And I met you through NCI
Yeah.
and was really fascinated with sort of the evolution of your business.
Okay.
I'd like you to talk a little bit about that and why you named it the name you gave it.
Oh, sure. Okay. So background, I was born at a very young age.
I shared that with you.
Yeah. So I have a diverse background. I've been in the related industries for 50 years. And I spent quite a bit of time doing home remodeling in the 70s, 80s, moved into full-time plumbing, and then insurance renovation restoration work. And I remember the day when I hired the AC guy to do a renovation on a job, and I said, no, wait a minute. He works hard in the summers, kind of laid back in the winters, and I paid him this much? So I went and got my license. And as 93, I got into the HVAC business in particular and kind of kept some other aspects of our business. But that was service, residential mostly, and installation, mostly add-on replacement. We developed a quick aversion to new construction for obvious reasons, because I never felt like I could learn the skills and develop the skills and practice the skills competing to be the low bidder. It just didn't seem, even Alan Shepard said that when he was sitting on top of a Redstone rocket on his first trip into space. He realized every part of this ship was built by a low bidder.
Ooh, that's a scary scary thought right there.
It is, especially when you're strapped in and it's pointing to the sky. And, you know,
You're underneath a giant
other
bomb.
people have that button on the countdown. So, you know, so we tried to target our market to some kind of skill building and opportunities where we could, you know, learn and perfect our craft rather than just get into the sausage making business, if you will. Just grind, and case and sell another one. It didn't take very long for me to realize one thing. One of my best mentors, a guy named John Haldenstein out of Austin, Texas, he introduced me to the idea of load calculations right from the start. You need to do a heat load on a house. So I didn't know that most people didn't do that. So my introduction was, hey, I'm going to do this every time, and I've done thousands of them since then. It's a very interesting way to get into the business, realizing you have to kind of map out your target before you start loading and shooting at something.
So you were tricked into doing this.
I was led to believe that everybody's doing it.
Yeah.
When I used to tell that to my mom, that didn't work. So it's kind of different. But soon after that, I realized there was other aspects of the industry. So I developed first company was Tradesman Heating and Air Conditioning. And let's say 6 years later, I developed a sister company called Trade Winds. And that was first to be an alternative energy company. I actually went to Africa, and I was on a sort of a agricultural mission, alternative energy, water pumping, solar kind of stuff. And I said, I really want to ride that crest of that wave in America because I see we need to make some changes in the way we consume energy, all kinds of reasons behind it. So in '99, I developed a second company, Tradewinds Appropriate Technologies. And I immediately found out that we're not ready for this culturally. We are not ready to go off the grid. I mean, there are some people that go off the grid and you never see them again. And every once in a while they ride by on a Buffalo or something. And, but it's just not mainstream.
We read stories about them later on.
Yeah. So I refocused my attention. I had these two companies going and I decided we're going to get there, but we're going to have to take baby steps.
Mm-hmm.
So, and the analogy works pretty good because we need to have a smaller footprint if we're going to go to any kind of alternative energy. So the baby steps to get there is how do I wean myself off of this mega consumption in my home? Well, what's the elephant in the room? I got an AC business and I found out that we're the elephant in the room. If we don't get the operational control and design of these systems down to where they're very efficient and manageable, downsized, we're never going to achieve any kind of hybrid off the grid or totally off the grid. I have since done totally off the grid, solar powered, geothermal, heated and cooled, 2,100 square foot type houses that with rainwater collection that are completely autonomous with a backup generator for the time that the cloud cover comes over for 7 days and it's 20 degrees out. Mm-hmm. But I actually had a call from a client of mine that when we had the big freeze in Texas mm-hmm. and power outage was mass, hundreds of square miles. He said, Paul, I'm sitting in here. The lights are on, the heat's on, water's working, and charging my cell phone. I'm calling all my neighbors who have no heat, no lights, no phone chargers, and I'm inviting them over to the house. I want to tell you that everything that you put together in this comprehensive design is working, and I'm off the grid, and they coming back. So it's kind of cool because we were able to do that, but only a few people could adopt that energy alternative lifestyle. Talking with Bill here, you have a paneled house.
Yeah, close to that. We're still grid tied. The grid is our battery.
Yeah, but it's a paneled house. It's
right.
Solar paneled.
Right.
Indoor paneling is one thing. Solar paneling is another. It's a pretty cool way to do stuff, and you can even charge your vehicle off your roof.
That's right.
It's pretty cool. So I mean, it wasn't long after that I was introduced to NCI. This is a pretty cool story. We got a little bit of time here. I'll tell you, I was starting to do some training because I'm really a teacher at heart. I've worked in schools. I've worked in publishing companies, running the curriculum department, proofreading and stuff like this. I have a background in education. So whenever I learn something, I want to show somebody what I learned.
Yeah, that's half the fun of it, isn't it?
So yeah, it is. It's very rewarding. So I was in Tyler, Texas, at Eddie Maddox's place. They've been in business since the 30s. The Maddox Heating and Air Conditioning Company.
1930s, right?
Yeah, right. The 1930s. And
that's almost going to be 100 years soon.
Yeah, and I was teaching a Manual J class. At the same time, I sent my team to a NCI class, and they came back from the class, and they said, "We know something you don't know." Uh-oh. So I called up NCI and I said, "When's your next class?" Well, it's called boot camp. It's in you have to come all the way to Cleveland, and so I signed up for boot camp. Funny part was, in order to enroll, you have to have a prerequisite. You have to take the air class. So I made a deal. I'll take the air class at night and boot camp in the daytime. So I was
double dipping.
Double dipping.
That's a big week right there.
Self-instruction at night and then absorbing everything these guys are throwing at me in the daytime. I took the final I had to take the final on the air class first. Rob Falk comes up to me with my test score. and has a 0 on it. Oh, what'd I do? I must have gotten the dots off or something. He said, no, you got 0 wrong.
He was like that.
That's wrong.
That was Rob for sure.
But back up just a second. I got a little ahead of myself. I was sitting in my office. I have been teaching some annual J classes, working out formulas to calculate BTUs. And everything that I was reading, there were typos, numerical typos. Now, I said I work for a publishing company. One of my jobs was math curriculum. And to proofread math curriculum, you have to know all your formulas. You can't just proofread the number. Well, that's supposed to be a 9, it's a 9. But is it right? Is the answer 9?
Yeah.
Okay, so in all the publications I was reading, I was doing the math, pretty good at math, and the math was wrong.
Uh-oh.
And I'm on the phone with my work colleague, Pat Chesney. I said, Pat, there's got to be somebody out there that knows more about this than we do, that can get the math right, because they've actually done it in the field. You can do all kinds of theoretical stuff, and the numbers don't have to add up because your life doesn't depend on it. But if you're calculating fuel for your airplane, you got to be good at math.
You better be good at some math.
And I'm under promising and over delivering to my customers because I want to be the best at what I do. I can't be bad at the math, and I can't have my instructor give me bad math. I got to have some. So I'm in this state of mind, like I don't know where to turn. And literally I had a stack of unopened mail and junk mail sitting on my desk. I picked up the top thing, and it was contracting business. And I'm flipping through it, and I read this article on how to field measure BTUs. And I'm sitting there at 5:30 in the afternoon. The phone has gotten quiet, and I'm going, whoa. This guy has calluses on his brain from doing this in the field. You understand what I mean by that? This guy has field practical experience because he's applying these numbers, and I'm actually doing the math, and it's working. So that it was too late. I'm in Texas, so I call in the morning, and that man right over there, Dominic Carino, answers the phone. We're on the phone for an hour and a half. He was born and raised in Queens, New York. So was I. He delivered Newsday, the local Long Island newspaper. So did I. And he came from a publishing background. My dad was the vice president of Barnes & Noble. Okay? And I was a proofreader and editor at a publishing company. And he's moving into HVAC migration. So did I. It was like, you're a brother from a different mother. Yes.
Did you two know each other growing up?
Not at all.
Not a bit.
Not at all. But when we connected, okay, you want to add 6 degrees of separation to get it even closer? Dominic, later on, we got involved. I started doing teaching with NCI in about 2005 or something. There are no records. It's back before they had written records. Papyrus and stuff was invented. But Dom and I are meeting at Austin Energy. We're doing some like pilot program type stuff and interfacing with utilities because they have a stake in this game to save energy in a real way. And most wish-a-want programs don't do that. They collect ratepayers pay for programs because they can raise the rate and then give away the money back to people. So it's not in robbing Peter and paying Paul. It's robbing Paul and paying Paul. Okay.
And it's more than just you, Paul.
Yeah. Okay. Yeah. If it was Paul.
So Paul got paid either way.
I don't care if Peter's it's flowing this way, but Yeah. Okay. So here's what's going on. We're having this meeting scheduled, and we're sitting in a restaurant in Austin, and there's an Andy Warhol picture painting on the wall. It's this eclectic restaurant in Austin. They all are. Yeah. But this is renowned for its breakfast. So we're having an early morning breakfast. And I said, I got a story about Andy Warhol. My brother's mother-in-law, her name is Carol Baker, famous actress from the 50s and 60s. Okay. And she has a Warhol. Okay. And her son offered to take it off the wall, protect it for it. He brought it home to Palm Springs or something. You know, I'm going to look out this $1.5 million painting. Mom, let me take it home. Keep an eye on it.
Yeah.
Yeah.
I'm telling the story to Dominic, and Dominic says, Carol Baker? And it's like this Niagara Falls thing, slowly I turn. He says, my sister went to high school with Carol Baker's daughter, Blanche, in Italy at the American School in Rome. I said, well, Blanche is my sister-in-law. And these two hadn't seen each other for years. I gave him Blanche's number. He gave it to his sister. They got back in touch. She was living in Connecticut. My sister-in-law was in the Bronx. They hadn't seen each other since Italy.
Wow.
So, I mean, it's kind of this meant to be kind of stuff.
Yeah.
It's pretty fascinating.
It is.
Anyway, in the course of human events, we've been developing these things. Specifically, the black hole of the industry is design. There's a tremendous aversion to adopting the idea that if you're going to measure it, you have to design it, because you have to develop a target.
Yes.
To test to see if you're within the parameters of your design. If you don't have a target, you can measure anything and call it good, but still you're not constrained to that target. You know, there's boundaries, there's parameters that you can be within tolerances, but I can hit the broadside of a barn in air conditioning. But if you can put the bullseye on the barn and, you know, aim at it, measure your results, then you get the satisfaction of closing the loop. I think I've heard it described in the way that there's such a thing as quality control and quality assurance. And the definition is important. Quality controls mean doing the same thing over and over and expecting the same results. And that's good. If you're Toyota and you're building a floor mat and an accelerator pedal and you get it right, then when you push the accelerator pedal, the floor mat doesn't catch on the accelerator pedal and then drive your car through the window glass.
It's a good thing.
If you're really good at quality control, if you get it wrong by a order of magnitude of 18 million vehicles. You recall. If you get it wrong in one model, then it's a million, but the recall has to go to 18 million because the press got a hold of it and they amplified the callback into this major meltdown. Don't try a Toyota, it'll kill your mother. So that's quality control. Quality assurance has a feedback loop. That's the part I like about it is you build it, you design it, you build it, and you test it. And the stakeholders have a voice, like, cockpit resource management. A lot of planes are crashing, and the industry learned that the co-pilot was intimidated by the rank of the pilot, so they wouldn't say anything when they're about to fly into a bridge in Washington, D.C. We had relatives on that plane. I had been at a Christmas party with that family that was in that plane.
Wow.
And when they drove into the bridge, I also had a friend who was a pilot who gave me the transcript from the cockpit recorder. And the co-pilot is saying, this doesn't look right. It's kind of like a lot of ice on those wings, isn't there? But he's not directly challenging the pilot. He wants to get on the runway and get it. They've been delayed and de-iced and delayed and de-iced. He couldn't assert himself and say, hey, we got a problem. Another thing, the pitot tubes were iced up and the thrust was a false reading. So their position on their throttles wasn't enough for takeoff where they do that rotate. They didn't really have it. The co-pilot should have firewalled the engines and they still had room to take off. The last words they said, we're not going to make it, says the co-pilot, and the pilot says, I know.
Wow.
So that's a little segue from quality assurance, but quality assurance is being able to speak into the process, design it the best you know how, but there's also, in our industry, there's something called system effect, which means the best intentions of my design are going to have modifications at the end. If I just rubber stamp it, put it in like this and walk away and never measure, I don't inform myself as what did I miss? Why isn't that working like that? What's going wrong? And so that quality assurance says you have the authority at the end to test, measure, and verify and feedback and say, it's either got to change or, maybe we're not doing the math right. Maybe we're taking values of windows and not taking them into account for shading, whatever it is. So I think that's part of what I saw in the industry is like, we're not starting out with a basis of design. So if you don't have a design, it's like heading out on the road. If you don't know where you're going, any road will get you there.
Mm-hmm.
And I felt like it was important to try to get the message out and how to do a manual J. Okay, so you guys can ask any questions that you want, but I want to tell you something while you're thinking of that. I got this thought last night. I want to describe my colleagues in the industry as flat earthers. Okay, so you know the story about Galileo. He's looking up, or Galileo, or however you say it. He's looking up as an astronomer. He's good at math, and he sees all this rotation and all this roundness, and he's calculating that what I'm standing on is not flat. And everybody else is going, we're going to excommunicate you, and we're probably going to make you drink the Kool-Aid because you're not adopting the party line. In the back of our brains, we're convinced it's flat. In the front of his brain, he's seeing something different. The back of your brain is the hardest thing to influence. The front of your brain is always asking questions. Okay, so he's encountering a revelation. This is not what we thought. The math is not adding up. This is not flat. Okay? All right, so what do we do in the industry as far as design? How would you see a flat earth analogy apply? What's the most common way that the rank and file AC guy will assume the design? Let's say, is there some sort of correlation of square foot?
Yeah.
Per ton, yeah.
Per square foot, CFM per square foot.
CFM, or CFM or square foot per ton.
Yeah.
Yeah. So
there's also
if I'm part of the denomination that does 500, 500 club, Fortune 500.
All right, 500 club.
Yeah. So all right. So I've heard it called lots of things like they have a race, the Daytona 500, right? Mm-hmm. Go round and round in circles.
Nice.
Anywhere. Okay. So when you use that 500 number to develop and match for your air conditioning, are you a flat earther?
It's possible.
You're only using two dimensions, length and width. Okay. All you're looking at is the floor. I was talking to a guy that's actually, I think he's actually here at this conference. We're talking about this concept. He said, we're not selling carpet. So why are we just measuring the floor? I thought it was great. We're not selling carpet. All right, so we're missing two more dimensions. We're missing the elevation, the height of the building, which creates the walls. When you have the walls, then you've got the glass. If there's glass is not the same thing as the pink stuff in the walls. So you have these huge gaps or aberrations in your continuous insulation barrier. If you don't count the glass, that's 50% of the load in a common house, in a standard house. So when you take that into account, if I'm doing 500 square feet, I actually did this. Multiple classes. I developed 12 online courses for TACA, in Texas Air Conditioning Contractors Association.
Mm-hmm.
And we started with a live classroom, then we recorded, and then we adapted it for online so guys can stay home and get their continuing education. We actually got the first approved continuing education class in the state of Texas through. It was a lot of fun because one of the questions was, here's a house It's 1,250 square feet. How many tons? I showed them a picture of the front of the house. And actually, guys could deduce from that picture, that house looks like it was built in the 70s. It looks like it was built like to a HUD standard. Okay. There used to be a garage. It was converted. They could see 2 rooms look like bedrooms. And they inferred that if there's 2 bedrooms here, there's probably 1 in the back. And they really, with just a frontal picture of the house from the curb, they could pretty well estimate kind of close.
About the house itself.
Yeah.
What kind of construction it was,
Yes.
what kind of insulation
And they
it
were
had
pretty
with the
close
windows.
to the 500 square feet per ton. Actually, this house, when it was built, was my house, 1977, 498 square feet per ton.
You know, I've always wondered how people get a scale under that house to weigh it, to know how many tons.
Yeah. Well, actually, I delivered a 4-ton to a house, and a guy out in the country, and his kids were there, and I came with a pickup, and I was delivering a 4-ton, looking at my Ford truck going, how are you hauling 4 tons in the back of that?
It's a half-ton truck.
It's an F-150. They were genuinely amazed. I didn't have the heart to tell them anything different. When you're young, I mean, just that amazement is part of life, right? So I give these guys this challenge, and then I say, I replace the windows. They're low E. They have a reflective coating. They're argon filled. That attic is foam. I tore the front of the house off, the brick off the house, and the homosote off this 1977 house, the blackboard. I sprayed foam in those cavities. And then I put Austin, like limestone, back. This ain't the same house. Now what, guys? 500 square feet per ton? Hello?
Maybe not.
That would be like saying,
600.
yeah. This sounds like an auction.
Let's
How many
go for
bidders? Okay.
650.
Yeah.
Okay, maybe I'm gonna play a game here real quick, and I'm gonna go 1,300 per ton.
Yeah, I could do it with a dehumidifier.
Really?
Yeah. But I didn't do that. The dehumidifier came long after the install. We did geothermal, so we got huge latent capacity with geothermal because we're water cooled and it's a different beast. But it was like 750. But there's another story to that square feet per ton, and it's that a nominal ton is not a actual applied ton. A ton of air conditioning has a specific definition. You know what it is, don't you?
12.
The suction temperature converted from pressure is 40. The discharge temperature is 105. And the airflow across the heat exchanger coil has to be 400. If you take all those numbers at exactly those conditions, you get 12,000 BTUs. That's actually baked into the state law as a definition for the contractors, law in Texas. It's the definition. That's a ton. Now, when was the last, this is a history question, when was the last time you saw evaporator coils running at a 40-degree temperature?
8 SEER,
Yeah, thank you.
or when the filters get dirty.
So what refrigerant were we using?
That would have been R22.
Yeah, you might even have, you could have done it easily with 12.
Yeah.
With 22, we started to migrate away from that with 22. And in the early days, when you had fin spacing of 10 to 12 fins per inch, and excellent airflow, good heat exchange, you could run a cold coil because you weren't running marginally all the time. When you get a little water on the coil and you got 16 fins per inch, you know what happens to the resistance of that coil?
Yeah, it's static pressure. It climbs like crazy.
Tremendously. Yeah, so we're and as this evolution has taken place, in order to meet the EER or SEER, which is a magic number, right? Have you ever seen the formula for SEER?
I think I have.
Yeah, it's how many pages and how many How many X factors are in there, right?
A couple, one or two.
How many stakeholder factors are in there?
Uh,
Is that an unfair question?
no.
Stakeholder,
It's a
stakeholder
statement.
factor. Is,
Yeah.
is that a plate?
Yeah.
Stakeholder?
Yeah, well, there's
Bill's
science.
going to kick me off here in a minute. He's going to be like, you
Where's
got to
their mute
stop
button?
this. I get all those over here.
So you can't kick them under. That's why the double tables.
True. He might be able to kick me.
Yeah. So I think we'll do more cheesy jokes and then he'll give up because I started something. I got to stop it.
Yeah.
So in order to get SEER or EER, which is a more realistic real-time number, you have certain limitations. And the driving force is policy, not practicality.
Mm-hmm.
So, and I've worked a lot with engineers in-house at major manufacturers. I've worked a lot with utilities. I've done, measurement and verification programs on 5,000 houses in the Dallas-Fort Worth area. I have a lot of data. The Energy Conservatory loved me when I called them up and I said, I got 5,000 houses to do blower torque tests. You interested in the data?
No, probably not.
Oh, yeah.
Yeah, I bet Gary Nelson would have been all
What does
over
that
that.
sound like? Oh, yeah.
It sounds like
Rob Falk.
Yeah.
That's Rob Falk. Yeah, it's gotten into my DNA.
Sure. You do sound like him.
So we're watching the transformation of the evaporator coil from a small compact A coil to a tall as going up through the ceiling and sticking up into the attic like a Lennox 5-ton A coil.
Big.
This is, as tall as a teenager.
They're almost, some of them are bigger than the furnaces they're sitting on now.
Exactly. So that surface area gives you great efficiency, BTUs and watts. But what you're losing is your latent capacity.
Mm-hmm.
Okay. So you end up with a refrigeration conundrum where your sensible heat ratios are changing radically.
And those work great in dry climates, right?
I love high desert, 450 CFM per ton. I've worked on projects in Nevada, Henderson, Nevada, and I'm going, wait, you guys don't measure grains of moisture, you measure grains of sand. This is incredible. I mean, you can firewall that fan and get cooling capacity and you need it because you're in high desert, high altitude, air density.
Yeah.
But everywhere else, we lost our control of the sensible heat ratio.
What do you think that has done to energy usage, losing the control of that sensible heat ratio when we're talking about overall energy usage? Do you think that the higher efficiency equipment has actually done what was set out to do with going to higher efficiency, or do you think that's actually cost us in having to run more equipment like dehumidifiers?
Okay, that's a great question. So let me give you a word picture.
Because you got a lot of data, and data is a great thing too.
I'm going to do carbon dating on you.
Okay.
Okay. Did you ever have an Etch-a-Sketch?
I did.
Okay, so you're within the realm of we can relate to this, right? This is
Okay.
way before the iPad, right?
I've had a couple of those too.
Yeah. Okay. So you take an Etch-a-Sketch and you take one knob off. What do you got?
Not much.
Line drawer.
Yeah, a one directional drawer,
Two directions. You can go
up or
right down
down,
the knob,
or left or
you
right.
can go left or right, or if I give you the other knob, you can go up and down. Okay, so I've changed the comfort equation by sear chasing.
Mhm.
I'm losing control of humidity.
Mhm.
Okay, I give the thermostat a one knob Etch-a-Sketch and tell them to solve two problems: temperature and humidity. What are they going to do?
They're only going to be able to solve one.
No, they can solve two. How do you solve two with one knob?
Switch the knob back and forth.
It's a fair question. There is an answer.
All right,
So you gotta put on your thinking cap now.
I'll bite.
And what do customers do when they feel it's not comfortable in here?
Turn that knob down farther.
That's right. The one knob that we give them when the humidity is out of control, they try to chase it by turning that one knob we give them further and further to the colder.
Mm-hmm.
And still, we can't agree on this. Am I turning it down or turning it up? I'm turning up the cooling, turning down the temperature. You still hear that, right? What brand is your air conditioner? It's Honeywell. That's homeowners' initial response, or whatever it is now.
You can turn up the cooling because you can provide cooling.
Yes, sir.
And it's a chronotherm model.
Yeah. So you know,
There's a throwback
I
for everybody.
I actually went down to Walmart and I bought an Etch-a-Sketch. And I was showing my son, this is what we're doing to these people. We're giving them one knob Etch-a-Sketches. And it's like, it's got to be different. They got to have the control of two parameters for comfort.
I like this analogy.
They got to have two.
Yeah.
And we'd only give them one. So what we developed over the years, like I said, our passion has been for design. We're teaching other people. We've learned how to do manual J. We do it all over the country for our customers. We have clients in Massachusetts. We have a couple in California. Not just high end. It's just people like contractors that I meet through our network, which I like your network.
Good.
We're going to help more guys tune into this. What we decided we could do is teach them or do it for them. But we just don't want to do it for you. We want to teach you, do some for you, but we want to get you to go solo at some point because you're going to need to do this so you can own this. Right? Teach them to measure and verify, test and balance, but also do the design side. So the idea is to be able to capture this control of things. And what we found out is we have to build in a dehumidifier into the standard operating procedure. Because we just had a conversation with Ben Lipscomb about what's going on with electrification.
Mm-hmm.
Heat pumps are taking over the world. But heat pumps have a delta T of maybe 28.
Mm-hmm.
Replacing a furnace that had a delta T of 65.
Mm-hmm.
What do you think that does to your ductwork? What do you think that does to the comfort feel in a room? What do you think that does to the disparity between a dedicated fossil fuel furnace and an air conditioning unit? You only can have one, and you have to decide, am I going to oversize for cooling in a cooling climate or undersize for heating in a, you see what I mean?
It's a conundrum. And it's a challenge for every contractor out there that's trying to do heat pumps, especially in cold climates today.
Well, we're doing heat pump training in California with NCI.
Mm-hmm.
We're doing manual J training, and these guys are going. We're doing like for like swaps.
Yep.
In a utility sponsored program, and we're getting blowback from the customers because my condenser swap out to a heat pump just cut my heat output in half
Mm-hmm.
because my furnace is always twice the size by convention because your airflow needs to match your condenser.
Mm-hmm.
And usually you get like a 4-ton, you'll need, 80, 100,000 BTU furnace. But when you go to a heat pump, it's the same BTU output relatively in either condition. And all of a sudden, I don't have that 80,000 BTUs of toasty heat. I've got 40,000 BTUs, maybe. And on a cold day at Mammoth, I got 19 or 10,000 BTUs.
Mm-hmm.
So my heat comfort equation has just collapsed.
Well, you got to be real careful putting where you put that cooler air now.
Yes, because, right, customers, especially us aging population with direct airflow on our skin over 50 feet per minute, we
Mhm.
notice it.
Mm-hmm.
And if it's lower than our body temperature, it's cold.
So now you're adding manual T into your design classes?
Well, yeah, that's funny. Now, I read Manual T, my favorite HACA manual ever written. It was written by a community college teacher, a shop class guy. It's very different language, different approach. Not an engineer. I don't even think engineers. I've actually met some with a personality.
But meet Bill Spohn, PE.
Well, I met a guy who was working on a utility program, and he was the first guy that wasn't an engineer. Okay, Doug Garrett. Did you ever meet him?
Yeah, you mentioned it.
Yes. Okay. He was addressing a group of engineers, a large conference, and they asked him for his creds. He said, "Guys, I was a roofer." And he says, I tried to get into engineering school, and they gave me the Minnesota multiphasic personality inventory, and I scored high enough to have a personality, and they wouldn't let me in. What do you do when you're getting demeaned by a whole room of these guys with these snooty creds? What a response.
Nice. Yeah. Keep that in my pocket.
Get jealous. So the heat pump problem is a problem that isn't going to go away. It's a problem that's going to take a lot of finesse, a lot of understanding, a lot of reducting.
Mm-hmm.
Because if you have a high delta T, you don't need as much airflow in the heating mode of operation. But now if you swap out like for like and you don't do the duct work, all of a sudden you have undersized ducts.
Well, either that or we have to fix. If we leave those ducts, we've got to fix the shell of the house and reduce the load.
Yes, and that's true. And when we teach our classes, usually we get to this point of it's almost, I would say, it's a moment of recognition and depression. Our students hit the wall. They said, "There's no answer to this. I can't fix this." I said, "Well, guys, if you can think outside of the box, there's no way to fix what we've got here. But what if you worked on the envelope?
Yeah.
If you could change the envelope, your ductwork that's not repairable, not replaceable, let's say, it's still functional, but it's not replaceable. If you could change the load of the house, you could actually downsize."
Mm-hmm.
And you can start fitting into this envelope. And we're not talking about modeling and trying to make the data fit. We're talking about physical changes so that our measured data at the end does come out right. Does that make sense? We use our software to do computer modeling, and it's also a great sales tool, because you can show what would happen if we changed the window glass. What would happen if we added R49? That's another interesting topic. When I got into the industry, R19 was like the coin of the realm. What happened is it climate change that now R48 is and R30 is like minimum standard in a lot of places? How did we get from 19 to 38? Is it a different kind of insulation with the same R value?
I think the regulation builders just decided to increase it to try to minimize heat transfer.
Stakeholders. If I'm selling you electricity at 3 cents a watt, okay, and it's plentiful and we have energy resources like there's no tomorrow,
Mm-hmm.
I'm going to tell you R19 and sell you a lot of cheap electricity, and the more I sell, the better. But when it becomes a limited resource, supply and demand is under stress, I'm going to say, hey, I'm going to raise the rates and let's do R30.
Mm-hmm.
That's a stakeholder solution to a engineering problem. Fair enough? Okay. And so if you look at EPA, the same standard house that would correlate to an R30, they're recommending R48.
Mm-hmm.
Same house, same climate region.
Interesting.
Well, it's two different aspects of looking at the same problem.
Mm-hmm.
So the code references have stakeholders. The EPA has, trying to save the planet. So it's different. I'm not selling you a commodity. So I'm saying, yeah, ideally this should be this, but the builders are pushing back too. The national pushback and code development can be stakeholders who are building that want to keep the cost down to a value engineered solution. And it's not, I understand that. If you want to sell what you can to the least code requirement so that your cost of materials is under control. when we change a code, what happens to the builders? They have panic attacks because you just moved their cheese. You just changed the game. They don't know what their captured costs are. They don't know what kind of rate of return they're going to have on the building the house. They don't know if they're underwater. And it takes a long time for them to change the process to get things under control again. So now you're in unstable flight. And for any businessman in an age like this, where the value of the dollar is going down and the cost of interest is going up, you can't afford to change. Does that make sense?
Mm-hmm.
So, there's just a lot of stuff here, but
Yeah.
kind of.
So back to the dehumidifier thing, like, or dehumidifier, like you're not, so now you're teaching dehumidifiers, you're putting dehumidifiers in these designs. Do you see that using as much or more energy than what we had on, say, an 8-seer when you add together your cooling plus your dehumidification costs now?
I'll answer you with a cagey answer.
Okay.
I have concentric rings in my target.
Mm-hmm.
Comfort is the center bullseye.
100%.
Okay. If I do a really good job of designing my ductwork so I have an efficient delivery of my BTUs, capturing and not wasting, then I know I'm saving energy. Okay. If I design precisely on my manual J and manual S, then I'm using the least amount of compressor. So when it comes on, I'm certainly not sucking more watts out of the grid than I need.
Mm-hmm.
So efficiency is a subset of what I do. Because I mean, people buy a Lexus not because it gets MPG, right? They buy it because it has this incredible sound when you shut the door. And
Or
then
sometimes lack of sound.
Well, that's the sound. We actually took the sound liner from Alexis, which is pretty incredible material. We had this high net worth individual customer who wanted to build a log cabin. They wanted to have a secretive cooling system installed that you couldn't see, hear, but you could climate control it, and it's a log cabin. And he was 8 miles from the nearest electric pole. So we put in a CAT generator. Right? It had a English 8-cylinder Ford engine. It was running on propane. They didn't want to do diesel. They didn't want to smell the diesel. We had concrete block walls filled with sand as a sound barrier. We're 400 feet away, burying cable into the ground. And I was told where we put this air handler, they can't hear it. So it's a 2-room cabin, dog trot style. So it's got like sleeping quarters and common living spaces here with a breezeway in the middle. They call it dog trot in Texas. So I put the air handler under the dog trot. I used the Lexus insulation to sound blanket it, and we put the stuff on, the equipment on springs with PVC pipes full of sand. There's no low frequency conduction. There's no high frequency conduction. We actually had the builder put his ear on the floorboards of this deck. He could not hear the thing running at high speed.
Wow.
So that was the Lexus thing, but people buy comfort as a luxury. But, that's what they really want. Why do we have central air conditioning? So we can save the planet?
Now, if we wanted to reduce energy usage,
so we could live in the South.
Yeah.
So how are we doing on time?
We're doing all right. We're up to about 50 minutes. We've had a few people bouncing in and out watching here. So we got about another 10 minutes or so we can go for.
So ask me some questions. You taking notes?
Bill's got notes.
I was taking notes. Going back to the smaller energy footprint,
Sure.
is that something that you get business for because you're known for what you do, or something you feed back to your customer as you get a job to do.
Okay. Yeah, it's interesting. We have a website, manualjdesign.com. We don't advertise. I mean, this is,
You just did here.
I know that I was just going to say, this is like our, our first podcast ever. And,
We'll be nice to you. I think we already have been nice to you. Keep going.
yeah, you're doing that. You're doing it. So, I guess there's two things that are going on. I do a lot of training for NCI and meet a lot of contractors. A lot of contractors that want to raise the bar in what they do. And they don't have all the skill sets yet. And so we come in and help them. We have clients that come to us by referral mostly, and they want to build an energy efficient home, for example. And then we ask permission to work with architects and engineers. We want to re-educate them, but they can't know we're doing that. And this is what we do. I'm going to give away a secret. Is that all right?
That's absolutely fine. It's your secret.
You and all of our friends listening right now.
Yeah. So you told me there's hardly anybody watching. So, okay. So here's what happens. My son or I get on the phone with the architect or engineer on a custom home. We just have a conversation. It says, look, we've been tasked with bringing comfort to this incredible design. This house is beautiful, no question about it. It's accommodating. It has all the features that they want, but the intangible is comfort. Now our spaces are not living spaces. They're mechanical spaces, and we need room to get from point A to point B. And we see here in the design that you've got a slope or a truss, and you're giving us 8 inches. And I see that you had somebody on your team do a reasonable facsimile of a duct design, but that's not going to work. I need space. I need room. If we don't get air delivered over this point, that part's going to be unusable. It's going to be uncomfortable. It's going to be noticeable. So they're not going to enjoy this space that's been crafted with all the effort you put into it. And here's what happens. As we're having the conversation, the architect or engineer segues and say, can I just break into this conversation a minute and ask you a question about my house? And when that happens, we realize we just connected. That comfort needs space outside of your beautiful aesthetic design. You're going to have to provide all these chases and avenues for us to get past these beams that you put into place. They need to be truss joists or whatever is going on here. We have got to be able to deliver. We can work together, and many times we get invited to their personal homes to do an assessment.
Eric and I were at the Building Science Summer Camp about a month ago, and there was that presentation where he talked about the 100-year building.
Mm-hmm.
And I might get this wrong, but it was something to the effect that architecture should be first practical and first functional and second beautiful.
Yeah, it says form follows function.
Yeah.
Where did I hear that before?
No, I don't know.
Yeah. It's incredible. Yeah. So, and when they understand that we have been really kicked out of the house, and you remember a time when fur-downs in the conditioned space were the norm?
Mm-hmm.
If I had a beautiful house, I could have a hallway with a duct running through it and registers going to each one of the rooms, all within the controlled space. Now, you're talking about 1,300 square feet per ton? There's a guy in Fort Worth named Armando Cobo. You met him?
Sounds familiar.
So he's a designer, has great engineering skills, and he's designing houses with all of his ducts within conditioned space. And they don't stop until they get to 1,400 square feet per ton.
Mm-hmm.
And holding the comfort and control. You do have to have a subsidiary or ancillary humidity control to do that. You can't really deliver that little amount of air in that big a space, whatever it is. The ratio is just out of control.
Yeah.
So dehumidification Does it need to be ducted?
Does it?
Does not. Joe Stieberg proved that in a Pulte Holmes study down in Houston, the Houston study we call it. They put dehumidifiers ducted, they put them in closets, they put standalones, they did every which way, and they'd use two-stage equipment without dehumidifiers. And one of the most effective ones was the little stand-up one they put in a closet with louvered doors. It's vapor pressure. If I can begin to suck air out of the space, it'll find its equilibrium.
Right.
The more I dry, it sponges it.
Yeah. Yeah.
Without getting into the engineering of it, you can centralize a dehumidifier. Another thing that we did on dehumidification, I was constrained. Well, I had a person's home that was built. Is she sunk all of her retirement money into this tiny little nice house that the serial duck killer installed the AC. And she happened to be retiring as a clerk for a lawyer, legal secretary. She pulled a couple strings, and this guy got a lawyer letter, and he literally had to take his AC. When it was set out on the curb, he had 4 hours to pick it up, and he had to reimburse her. That doesn't happen. She was a widow. Just a heartbreaking story. She just was trying to find a house to age in place. And the humidity was out of control. All kinds of things wrong. All right, so we had a very limited scope and budget that we could fix the problem. We downsized by a ton. And what we decided to do was get a Frederick standalone portable air dehumidifier. Nicely built, has a built-in condensate pump. We set it in a pan in the attic and we, drained it out. I thought that's the best we can do. We have a 2-ton air conditioner. I'm not going to duct a dehumidifier into a 2-ton because it's going to kill my sensible cooling. It's just going to overrun it. What we found out was the house is running at 45% relative humidity with the dehumidifier in a foamed attic. So now the envelope is cathedral. We brought the attic into the envelope, and it's consistently running in the mid 40s.
Nice.
We did it in a doctor, pharmacist at Baylor guy at his house. And same thing. We got there too late to inform the way the ducts were run. There's just no way we're going to tie in the dehumidifier. We put it in the attic. Same thing. Got in the mid 40s. Just turn the thing on and let it go. They don't even give them a control.
Yeah.
So, we're finding. I've been a member of ASHRAE since the 90s, and I got all those volumes. Right. I'm flipping through when I'm looking. I think the HVAC design, whatever it is. There's a ASHRAE comment that says that the standard air conditioner off the shelf will not get you below 55% relative humidity as built. It's just, it's like this warning statement that Surgeon General has determined that if you operate with these efficiencies, you will not get it's just not. They call it dehumidification is a consequence of space cooling.
Yeah.
Which consequence means it follows with, but there's no etch-a-sketch dial to control that. So, you can do it without precise design and stuff, but really a dehumidifier in most applications where you have to deal with excess humidity, especially in a high efficiency house, the sensible heat ratio changes the indoor humidity, showers, respiration, plants,
Cooking,
whatever.
Cooking, yeah.
Yeah, cooking and everything. You get 60-40 sensible heat ratio. And there is no standard off-the-shelf air conditioning system that will do that. Dehumidifiers take up the slack.
Yep.
Yeah. Well, we're running up against our time limit here, so we're gonna have to wrap things up.
Need to put another quarter in the thing, or what?
I'm not sure.
It's now qubits is what you would put in for measure questions.
Qubits for measure questions. See Joe Medosh.
Yes.
You got qubit questions. I'm not in charge of the schedule. I was just told that this was the time slot we get, so
Okay.
that's what we get.
Yeah.
So
All right. So where do I
What,
tap my card to give you a tip for this?
any last thoughts or
No,
comments
just-
from people from?
Well, I just want to say meeting you guys and being able to exchange ideas like this has just been a real pleasure. I really appreciate it. I think everybody in our industry needs to focus on how do I get the skill set of design, either have somebody do it for me or learn how to do it myself. It's not that hard. I'll tell you what we have developed. We've developed a 3-day class with laptops provided, with software that's unbridled, it's full version, not a demo. We set it up around the country. We get guys going up and running. They don't have to borrow their daughter's school laptop and get the password and all that stuff. We're up and running. We teach them in 3 days to do manual J, S, D, and T. And I think that's a great way to get off the ground. But any way, shape, or form that our colleagues can get into this side and, whatever it is, overcome the resistance and quit doing the rules of thumb and be flat earthers.
Yeah.
I think it's going to help all of us.
That's awesome. Where can people go to sign up or find out more information about this?
Simple manualjdesign.com.
Manualjdesign.com.
Yep.
Awesome.
Got it. We'll make sure it's in the show notes too.
Okay.
Our
Whatever
podcast.
that is.
Yeah.
Yes, wherever that is, wherever that exists.
Whenever we put it out on the podcast
Yes.
channel, because right now we're live out here on YouTube. I'm gonna throw that in the comments right now. Manualjdesign.com.
That's the book, not the guy. MANUAL.
Manuel.
Manual, not Manuel. Okay.
Thanks so much for coming,
Thank you.
joining us, Paul. And I thought I knew you, but I know you better now. And I continue to be impressed.
Thank you.
Well, thanks everybody for joining us, Paul, Bill, and everybody out there watching, and whoever's going to watch this later, because I'm sure some people will go, wait a minute, who are these guys and why are they on my YouTube channel now? So thanks everybody, and we will see everyone next time.